Hello math learners, Hassan here. Today we are delving into functions in Algebra 1. Now, don't let the term scare you. By the end of this video, you will have a clear understanding of this topic. So let's start functions. In this case, the relation pairs inputs and outputs. Therefore, we get a relationship in a set of ordered pairs. When a relation is given as ordered pairs, the x coordinates are called inputs and the y coordinates are called outputs. A relation that pairs each input with exactly one output is called a function. So for example, over here, let's see these ordered pairs. We have 1, 2. So this 1 is an input and 2 is the output. We have 2, 4. So 2 is an input, 4 is an output. We have 3, 6. So 3 is an input and 6 is an output. 4, 8 means 4 is an input and 8 is an output. And lastly, we have 5, 10. So 5 is an input and 10 is an output. Now in this input and output relationship, the set of the first components of each ordered pair is called the domain. That means the inputs are called the domains. And the set of the second components of each ordered pair is called the range. That means the set of all the outputs are called the range. So over here, our domain is 1, 2, 3, 4, 5. And the range is 2, 4, 6, 8, 10. So you can see that we are collecting all the x components to make the set of the domain, and we are collecting all the y components to make the set of range. And we use braces to represent this set. Now for the validity of a function, a single x value cannot generate two y values. If it generates two y values, it's not a function. However, if a single y value is generated from two or more x values, it's still a function. And we'll see this in a moment over here. So for example, over here, let's say we have all these inputs over here and we have all these outputs over here. This kind of diagram is called a mapping diagram. So just to make a note, we call this kind of diagram as mapping diagram. Now let's see the step-by-step approach to identify a function. For this mapping diagram, first we'll identify the input values. We'll also identify the output values. Now, if each input value leads to only one output value, we classify the relationship as a function. If any input value leads to two or more outputs, we do not classify the relationship as a function. So you can see over here, P is leading to one output value, Q is leading to one output value, R is also leading to one output value. Now, since the arrow is going only once from each input, the first one is a function. Let's look at the second one. We can also see that the arrow is only going once from each input. So it's also a function. Now for here, we can see that this input is generating only one output, but this input is generating two outputs. So remember, if any input generates two outputs, that relationship is not a function. So in this case, this is not a function because any input cannot lead to two or more outputs. Now, we might wonder whether this can be a function over here because this output is coming from two different inputs. Yes, if any output is coming from two or multiple different inputs, it's still a function. Remember that the arrow cannot go to two outputs from the same input, but the same output can come from multiple different inputs. Let's look at this practice problem over here. We'll identify whether each relationship is a function or not, and we'll use these step-by-step strategies over here. For the first one, we have -2, 2, -1, 2, 0, 2, then 1, 0, then 2, 0. So we identify all the input values. So if we classify all the input values, we have -2, -1, 0, 1, and 2. And you can see that each input is giving only one output. Since each input is giving exactly one output, this relationship is a function. Now let's look at this second one over here. we can see we have these inputs 4, 8, 6, 4, 5. So the input values are 4, 8, 6, 4, 5. We can see that these two values are same. So these two inputs are giving two different outputs. So this 4 is giving 0. At the same time, 4 is giving 3. So you cannot have a single input giving two different outputs. So this relation is not a function. Now let's look at this one over here. We can see that the input values for number C is -2, -1, 0, 0, 1, 2. Again, we can see that the same input 0 is giving two different outputs. So you cannot have this as a function. And lastly, we can see that over here we have -1, 3, and 11. And the output values are 4 and 15. Each input is giving exactly one output. -1 is giving 4, 3 is giving 15, and 11 is giving 15 as well. So each input has exactly one output value. So the relation is a function. An important note over here, if any output comes from two different inputs, it's still a function. Remember, any output can come from multiple different inputs, but the same input cannot give two different outputs. That's the condition for a function. Earlier, we saw how to find domain and range from ordered pair of points. Now we'll see how to find domain and range from a graph. So the instruction over here is find the domain and range of the function represented by the graph. In this case, we can see that the points are discrete, meaning that the points are not connected. So the strategy over here is that we first read the coordinates. For domain coordinates, we just read the x coordinates of all the points on the graph. And for range, we just read the y coordinates of all the points on the graph. So first, let's read each of these coordinates. Over here, we have -3, -2. Then we have -1, 0. And then we have 1, 2. And lastly, we have 3, 4. Now, the inputs are -3, -1, 1, and 3. We can see over here that this is -3, this is -1, this is 1, and this is 3. So these 4 points are the inputs. So our domain is -3, -1, 1, and 3. For the range, we just look at the outputs. So look at the y coordinates. We have -2. Over here we have 0. Over here we have 2. And lastly we have 4. So these 4 points are the outputs. So the range is -2, 0, 2, and 4. You can see that we just write down the coordinates and then separate the inputs and outputs. Once we do that, we can just list the domain and range. Now we'll see how to find domain and range of a continuous graph. If the graph is a continuous line, the strategy is we identify the endpoints. So over here, for this continuous line, this is the endpoint on the left side, and this is the endpoint on the right side. Once we identify the endpoints, we can now find the domain and range. For the domain, we identify the leftmost and rightmost points on the x-axis covered by the graph. So you can see that the graph is starting from here and ending over here. So this region on the x-axis is the domain. So it starts from -2 and ends at 3. Now this portion can be written as a compound inequality. So you can write -2 less than or equal to x less than or equal to 3. This is our domain. For the range, we look at the lowest points and the highest points on the y-axis covered by the graph. So you can see that this graph is starting from here on the y-axis, which is -1, and ends over here, which is the highest point, at 2. So this portion is our range. So you can write these as a compound inequality again, from -1 to all the way to 2, And since this is the range, we use y as the variable. This is how we can write the domain and range for the continuous graph. Okay, so here the problem statement says that each graph represents a relation. Determine if the relation is a function. Then find the domain and range. So when we are given a graph, to determine whether that relation is a function or not, we can use a vertical line test. So you can draw a vertical line from left to the right and see if at any point the graph is meeting more than once. Now, from our observation, we can see that if you're drawing a vertical line right here, here the line is meeting at multiple points. So this relation is not a function. In number 2, if you draw a vertical line here, 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 at every line the graph is meeting twice. So this one is also not a function. So the answer is not a function for number 1. This is also not a function. Now to find the domain, we need to look at the input values shown on the x-axis, and to find the range, we need to look at the output values shown on the y-axis. Now on the x-axis, we can see that the starting value is -7 and it's ending at 6. Since this graph is continuous, that means we take the values from left to the right. So we start at -7 less than or equal to, since this -7 is included in the domain, we put an equal sign. We put x to represent the domain variable, and then less than or equal to, the maximum value is 6. Now the next thing is range. Range is the set of values on the y-axis. So on the y-axis, we can see that the lowest value is starting from here and is going all the way right here, because that's the point of this position. So the lowest point is -4 less than or equal to y to represent the range variable, less than or equal to +4. This is how we write the domain and range of this graph. Now let's look at number 2 here. For number 2, you can see that the lowest value on the x-axis is -3 and it's going all the way to +3. So you can write that the domain is -3 less than or equal to x to represent the domain variable, less than or equal to 3, which is the maximum value. Now on the y-axis, we can see that the lowest value on the y-axis is this -1 and it's going all the way to +5. So the range is -1 less than or equal to y less than or equal to +5. This is how we find the domain and range from the graph. Let's look at number 3 right here. To determine whether this relation is a function or not, we can again draw a vertical line and see if it meets at more than one point. So if we start from all the way to the left, we can see that at every point it's actually meeting the graph only once. Since the vertical line is meeting the graph at only one point, this graph is a function. So you can write that this is a function. Now let's try to determine its domain. We can see that there is an arrow indicating to the left and also an arrow indicating to the right. So this arrow is indicating that the graph is going all the way to the left, and this arrow is indicating that the graph is going all the way to the right. So on the x-axis, the minimum value which is going to the left is -infinity, because we don't know this lowest value. And also to the right, the highest value which the graph can go is +infinity. So that means we can write this domain as -infinity less than x less than +infinity, which means that it's all real numbers. So these -infinity and +infinity are not actual numbers, so we don't put any equal sign. Now for the range, we do the same thing. If you look at this y-axis, the lowest value on the y-axis is -infinity because the graph is going all the way down, and here, since the graph is going all the way upwards, the highest value would be +infinity. So the range would be -infinity to +infinity as well. Now we can also write these as all real numbers if we don't want to show using the inequality symbol. So all real numbers mean the same thing as this. Perfect. Now let's look at number 4. For number 4, to determine if the relation is a function or not, we can again try to draw a vertical line. Now if we try to draw a vertical line, we can see that this graph is meeting at 2 points with this vertical line right here. So this one is not a function. So let's try to determine our domain first. So on the domain, we look at the lowest value on the x-axis. So you can see that on the x-axis, the graph is starting right here and is going all the way to the right. These 2 arrows are indicating that the graph is going all the way to the right, which means the maximum possible value is +infinity. So we start off at -2 less than or equal to x. Since this value is included, we put an equal sign, but we put +infinity, and we don't need to put an equal sign right here because this infinity is not actually any number. Now for the range, we need to look at the y-axis. So you can see that the graph is going all the way downwards, so the lowest value is -infinity, and the graph is going all the way upwards, which means the highest value is +infinity. So we can write this domain as -infinity less than y less than +infinity. Since the -infinity and +infinity are not actually any numbers, so we don't need to put any equal sign. Now oftentimes we may need to represent the domain and range in interval notation. So let's see how we can turn these domain and range into interval notation, which is pretty easy. So interval notation, it starts off with parenthesis or bracket. So if the value is included, we use bracket. If the value is not included, we use parenthesis. So for this one, the domain, we have the lowest value is -infinity, so we put this -infinity, and then we put a comma, and then the highest value is +infinity. Now these 2 values are not included because we don't have an equal sign, so we put parentheses right here. So this is the domain, and for range we do the same thing because domain and range are same. So we have -infinity, comma, +infinity. So the comma is representing the gap between the -infinity and +infinity. Now let's look at right here. For this one, we see that the lowest value is starting from -2, comma, the highest value is positive infinity. Now this positive infinity is not included, so we put parentheses, but this negative 2 is included because we have an equal sign, so we put a bracket. This is the domain, and the range is from negative infinity to positive infinity, and we put parentheses because both of these negative infinity and positive infinity are not inclusive. This is how we convert the inequality representation into interval notation. Let's look at number 5. Okay, so to determine if the relation is a function, again we can try to draw a vertical line from left to the right. Okay, here we see that the graph is meeting the vertical line at exactly 1 point. So this relation is a function. Now to determine the domain, we look at the lowest value right here. In this case, we can see that there is no arrow right here. This is a closed dot, which means that the starting value is right at -4 and is going all the way to the highest value, which is +5 right here. So this is the part of the domain. And for the range, we look at the y-axis, so starting from -2 all the way to +6. So this is how we write the range. -2 less than or equal to y to represent the range variable, less than or equal to +6. Now let's try to convert this into interval notation. For domain, we have -4, comma, the highest value is +5. Now we need to put bracket to represent the inclusiveness of these two values. This is the domain. And for range, we need to put -2, comma, +6. Again, we need to put bracket to represent the inclusiveness of these two values. Now let's look at number 6 right here. For number 6, to determine if the relation is a function, we can try to draw a vertical line, and you can see that right here it's meeting at 2 points. Over here it's meeting at a single point. So again, this relation is not a function because the graph should not be meeting with the vertical line at more than a single point. So this is not a function. Okay, now we'll find the domain right here. To find the domain, we start off at the lowest value, which is -4, and go all the way to the highest value, which is this +4. Now we see that at -4 the graph is inclusive. So you start off at -4 less than or equal to x. Now at this positive value of 4, there is an open circle, which means that this 4 is not included in the domain. So we put less than 4. We don't need to put an equal sign because this value is not included. So this is the domain. Now for the range, we look at the lowest value on the y-axis. So you start off right here and go all the way upwards, and you stop right here. Now this lowest value, -7, again we can see that there is an open circle. So we put -7. Since this is an open circle, we just put less than. We don't need to put an equal sign underneath. Less than y, less than. The highest value is +5, but this +5, we have a closed circle, so we need to put an equal sign and then +5. This is how we write the domain and range for this graph. Now let's try to convert this into interval notation. For domain, we put -4, comma, +4. Now this -4 is inclusive, so we need to put a bracket, and this 4 is not included, so we put a parenthesis. For range, we have -7, comma 5. This -7 is not included. We put a parenthesis, and this +5 is included, so we put a bracket. Perfect. This is how we write the domain and range of a relation. Awesome. Quick recap. Functions are not as complex as they might seem. They are the friendly guides that make math more enjoyable. That's it for this video, and I'll see you in the next one. Now, let's get to study.